Hi, in this video we're going to look at a different type of linear equation of one variable, and that would be an absolute value equation. What is the absolute value? Well, the absolute value is denoted by these two vertical bars around the number or expression, and that gives the number or the expression's distance from 0. So for example, if we were interested in the absolute value of 10, that is 10, because 10 is 10 units away from 0. If we wanted the absolute value of -2, well, -2 is 2 units away from 0, so that would be 2. All right, well, how do we translate this into equations? Well, this ax plus b is just an expression. If we had a value for a and b and x, that would give us a number. The absolute value of the number means the number, or the distance of that number from 0. This statement then says the distance, right, from 0 of the quantity ax plus b is equal to c. So c is that distance of this quantity from 0. So this value inside the absolute value could be equal to c, because could be equal, or c could be a positive number, and that could be equal to c. In that case, ax plus b could equal c. So that's one of the possibilities. Right. We could also have that the part inside the absolute value could be equal to the opposite of c, because, for example, -2. Right? The absolute value of -2 is 2. The absolute value of 2 is also 2. Right? So there's two numbers that could be put in the absolute value, right, that could give you an output of 2. So when we're faced with an absolute value by itself equal to some number, we can split that into two parts, ax plus b equals c and ax plus b equals -c. All right. Another thing before we tackle an example, we need to always check our solutions. It's all good practice anyway. But for absolute value equations, it's necessary because we might have what's called an extraneous solution. An extraneous solution is an apparent solution that does not satisfy the original equation. These can appear when we're solving absolute value equations. They can also appear when we're solving quadratic equations, and later, as we'll see. All right, so let's find the solution set to the absolute value of 3x minus 2 equals 5. So again, this is a statement. It's saying that the distance of the quantity 3x minus 2 is equal to 5, distance from 0. All right, so here we have the absolute value. It's on one side by itself, equal to 5. And we know we can split that up into two parts. We've got the 3x minus 2 equals 5. Or we can also have 3x minus 2 equals the opposite of 5. All right, and now we'll solve these. We can add 2. It gives us 3x equals 7. And that means x equals 7/3. Over here, we have 3x, or we're going to add 2x. We're going to add the 2. Add 2 plus 2 plus 2. So 3x equals -3. Divide by 3. X equals -1. All right. Now, these are apparent solutions right now. We need to check them into the original, make sure that they indeed solve it. So let's start with this one. We have absolute value of 3 times 7/3 minus 2 equals 5. Is that true? So, is that true? So 3 times 3 is 7. 7 minus 2, absolute value. 7 minus 2 is absolute value 5. Absolute value 5 is indeed equal to 5. So this is the 7/3 is a part of our solution set. Let's check -1. So we have absolute value of 3 times -1 minus 2 equals 5. -3 minus 2, absolute value equals 5. Absolute value of -5 is equal to 5. Also true. So this number, x equals -1, is also part of the solution set. And we can write our solution set. -1, 7/3. Okay. So we have our absolute values. And if we have absolute value by itself equal to some number, we can split it into 2 linear equations and solve those. Once we have those solutions, we want to check them back into the original and then write our solution set. Right. Let's do a couple more examples.